Welcome back to the World Model Podcast. We have journeyed from the abstract architecture of world models to their concrete applications in cars and virtual worlds. Now we arrive at the ultimate destination of this entire inquiry. Does this concept hold the key to artificial general intelligence? To answer that, we must first define AGI, not as a checklist of skills, but as a core capability, robust adaptation to novelty. A true general intelligence can walk into an unfamiliar environment, quickly infer the basic rules that govern it, and immediately begin to act effectively to achieve its goals. It doesn't need to be retrained from scratch. Current AI, including LLMs, fails catastrophically at this. They are prisoners of their training data. A model trained on internet text has no idea of what to do if placed inside a video game. A robot trained to walk in a lab has no idea how to navigate a forest. A world model is the mechanism that enables this adaptation. How? Through hypothesis and simulation. An AGI with a powerful but general world model would enter a new environment and begin to act. Its actions would be tests. It would drop an object to learn about gravity. It would push on a wall to learn about solidity. Each interaction would update its internal model of this new world's rules. Once its world model is sufficiently accurate, it can close the loop and begin planning, simulating actions internally before taking them, just as Dreamer does in a game. This is not a new idea. Cognitive scientists like Carl Fritzen and AI pioneers like Jürgen Schmidhuber have long argued that intelligence is fundamentally a prediction problem. The brain is a hierarchical prediction engine, constantly trying to minimize the error between its internal model's predictions and sensory input. World models in AI are a direct computational instantiation of this theory. This is why I believe the pure LLM path is a plateau. An LLM can describe a million worlds, but it cannot act in any of them. It has no mechanism for grounding its knowledge in sensory motor experience, for testing its hypotheses against reality. It is a disembodied consciousness trapped in a prism of text. The architecture of a future AGI will look far more like DeepMind's Dreamer than OpenAI's GPT. It will have a perceptual front end to build its latent state, a powerful transition model to simulate the future, and a reward model to guide its planning. An LLM might be competent within this architecture, handling language and high-level abstract reasoning, but it will be subservient to and grounded by the world model. My controversial take is that the debate is settled. The only plausible path to AGI that can interact with and understand the real world is through the development of powerful, scalable world models. All other approaches are either subsets of this or lead to specialized brittle intelligence. The challenge is no longer a question of if, but of how. How to make these models more sample efficient, more accurate, and more general. The architecture for a mind is now clear. We just have to build it. But to build it, we need new hardware. The computational demands of simulation are fundamentally different from those of pattern recognition, and that is the subject of our next episode. This is the World Model Podcast. We map the path to intelligence. Subscribe for more.